So in this video, we're going to talk about how to write equations of quadratics given 3 points that are on the graph. So remember, we have general form of a quadratic function, which is y equals ax squared plus bx plus c. So we can determine the values of a, b, and c to figure out the equation of the quadratic function. So to write a quadratic given 3 points, you're going to start off by plugging the x and y values of each point into the general equation y equals ax squared plus bx plus c. Since we have 3 points, this is going to give you 3 equations, which is going to form a system of 3 linear equations. Then what we can do is we can use the steps we talked about last semester to combine the equations to solve for the variables a, b, and c. Once you have the values of a, b, and c, you can go ahead and write the equation of the quadratic function. So let's look at this example. Let's write the equation of the quadratic function that passes through the points 0, 5, 2, 1, and 1, 2. So remember, general form of the quadratic function is y equals ax squared plus bx plus c. So what I'm going to do is I'm going to take each of these points and I'm going to form an equation based on that. So 0, 5 tells me that x is 0, y is 5. So when I plug into this equation, I get 5 equals a times 0 squared plus b times 0 plus c. So when I simplify this, I get 5 equals a times 0, which is 0, plus b times 0, which is 0, plus c. So this tells me that 5 equals c. So that's the first equation that I have to work with. Now I'm going to do my second point. So I have 2, 1, which gives me an x and a y value. So when I plug in, I get 1 equals a times 2 squared plus b times 2 plus c. So we have 1 equals a times 2 squared. 2 squared is 4, so that gives me 4a plus b times 2, which is 2b, plus c. That's going to be equation number 2. Now I have my final point, which is 1, 2. So that's an x and a y value. So when I plug in, I get 2 equals a times 1 squared plus b times 1 plus c. So that gives me 2 equals a times 1 squared, which is just a, because it's a times 1, plus b times 1, which is just b, and then plus c. So that's equation number 3. So what I'm going to do now is I'm going to combine these 3 equations, right? You can see that I have 3 equations now. I have c equals 5, I have 4a plus 2b plus c equals 1, and then I finally have a plus b plus c equals 2. So these 3 equations are going to form a system that I can now solve in order to figure out the values of a, b, and c. So what I'm going to do is I'm going to start off by combining equations 1 and 2. What I can do is I can take that c equals 5 and I can substitute it into equation 2. So that gives me 4a plus 2b plus 5 equals 1. I can now subtract 5 from both sides, and that gives me 4a plus 2b equals negative 4. I'm going to go ahead and call this new equation equation number 4. Now I'm going to combine equations 1 and equation 3. So when I do that, I have a plus b plus, instead of c, I have 5. So I have a plus b plus 5 equals 2. I can once again subtract 5 from both sides. So that gives me a plus b equals negative 3. I'm going to call that equation number 5. So now I'm going to combine these 2 equations that I have. I'm going to combine equations 4 and 5. And when I do that, I want to think about which variable I want to eliminate. Notice that in equation 4, I have 4a plus 2b equals negative 4. So let's say that I want to eliminate b. What I'm going to do is I'm going to take the second equation, equation number 5, and I'm going to multiply it by negative 2. So I have negative 2 times a plus b equals negative 3. So that gives me negative 2a minus 2b equals negative 2 times negative 3, which is 6. So now when I combine these 2 equations, I have 4a plus 2b equals negative 4. And I have negative 2a minus 2b equals 6. And when I combine them together, 4a minus 2a gives me 2a. 2b and minus 2b cancel, and that gives me negative 4 plus 6, which is 2. I'm going to divide both sides by 2, which gives me a equals 1. So I have a equals 1, so you can see I'm starting to get some of these values for these variables, right? I have c equals 5, a equals 1. Now I need to solve for b. You can pick any equation that you want to solve for b. I'm just going to use equation 5. So equation 5 tells me that a plus b equals -3, right? That's what I have right here. And I'm going to plug in a equals 1. So I have 1 plus b equals -3. I'm going to subtract 1 from both sides to solve for b, so that gives me b equals -4. So now I finally have the values of a, b, and c that I need to write my equation, right? I have a equals 1, b equals -4, and I have c equals 5. So I can plug this back into the general form, which is y equals ax squared plus bx plus c. And that gives me the equation y equals 1x squared minus 4x plus 5, right? And I can just rewrite that as y equals x squared minus 4x plus 5. So that is how you determine the equation of a quadratic function given 3 points that are on the graph. So just for practice, let's try another example. So let's write the equation of the quadratic function that passes through the points 2, 3, 3, 2, and 4, 3. So I'm going to write one equation for each of my points, right? Once again, I'm going to remind you y equals ax squared plus bx plus c. So I'm going to start off with the first point, 2, 3, which gives me an x and y value. So I have 3 equals a times 2 squared plus b times 2 plus c. So that gives me 3 equals a times 2 squared, which is 4a, plus b times 2, which is 2b, plus c. So I'm going to call this equation number 1. Now I have 3, 2, which is another x and y value. So when I plug in, I get 2 equals a times 3 squared, plus b times 3, plus c. So that gives me 2 equals 3 squared times a, which is 9a, plus 3b, plus c, which is equation number 2. Now finally, I have the point 4, 3, which is another x and y value. So that gives me 3 equals a times 4 squared plus b times 4 plus c. So that gives me 3 equals 16a plus 4b plus c, which is equation number 3. So just for reference, I'm going to just write my equations down here. I have equation 1, which is 4a plus 2b plus c equals 3. Equation 2, which is 9a plus 3b plus c equals 2. And then I have equation 3, which is 16a plus 4b plus c equals 3. So now I need to combine my equations in a way that I get one of the variables to cancel out. Notice that I have a plus c in every single equation, so that's going to be my strategy. I'm going to try to get c to cancel out when I combine these equations 2 at a time. So what I'm going to do is I'm going to start off by combining equation 1 and equation 2. So what I'm going to do is I'm going to write equation 1, so 4a plus 2b plus c equals 3. And then I'm going to multiply the second equation by -1 in order to get that c term to cancel out. So that is going to multiply every single term by -1. So that's going to give me the new equation, -9a minus 3b minus c equals -2. So I'm going to combine that with equation 1, which is 4a plus 2b plus c equals 3. And when I add them together, okay, I get 4a minus 9a, which is -5a, 2b minus 3b, which is minus b, and plus c and minus c are going to cancel each other out, leaving me with just 3 minus 2, which is 1. So I'm going to go ahead and now call that equation number 4. Now I'm going to combine equations 2 and 3. Once again, my strategy is going to be to get that c term to cancel out. So I have 9a plus 3b plus c equals 2. And then I'm going to do -1 times 16a plus 4b plus c equals 3. So that gives me the new equation, -16a minus 4b minus c equals -3. Then I'm going to add the top equation, 9a plus 3b plus c equals 2. So when I add these two equations together, I get -7a, 3b minus 4b is minus b, plus c and minus c cancel, and then I have that equal to -1. That is now equation number 5. So now on the next slide, I'm going to recopy my equations. I have equation 4, which is -5a minus b equals 1, and I have equation 5, which is negative 7a minus b equals negative 1. Okay, so now if I look at these two equations, I think a good strategy would be maybe to get the b term to cancel out. So I'm going to take the second equation and I'm going to multiply it by negative 1. So I have negative 5a minus b equals 1, and I'm doing negative 1 times negative 7a minus b equals negative 1. So when I do that, that gives me the new equation 7a plus b equals 1, right? Because I'm going to multiply every single term by negative 1. And then the top equation is going to stay the same, negative 5a minus b equals 1. Then when I add these two equations together, I have negative 5a plus 7a, which is 2a, minus b and plus b cancel, and then I have 1 plus 1, which is 2. So I have 2a equals 2, can divide now both sides by 2, which gives me a equals 1. So now let's go back and collect all the values that we found. So we have a equals 1, and now we need to find b. So we have to do, let's see, b equals what? So we're going to maybe use equation 4, right? It doesn't matter which equation you use. I'm just going to try 4. So we have negative 5 times 1 minus b equals 1. So we have negative 5 minus b equals 1. So to solve for b, I'm going to add 5 to both sides. And that gives me negative b equals 6. Negative b, remember, is like a negative 1 times b. So I need to divide both sides by negative 1 to get that negative to cancel. And I have b equals negative 6. So I have b equals negative 6. And then now I finally need to find the value of c. So I'm just going to pick one of these original equations that had c in it in the first place. So I'm going to use equation 1, which was 4a plus 2b plus c equals 3. And I'm going to plug in now all these numbers that I have. So I have 1 for a plus 2 times b, which is negative 6, plus c, and that equals 3. So now I need to simplify this. 4 times 1 gives me 4. 2 times negative 6 is going to be minus 12, and then I have plus c equals 3. 4 minus 12 is negative 8. Negative 8 plus c equals 3. And now to solve for c, I need to add 8 to both sides. So when I add 8 to both sides, I get c equals 3 plus 8, which is 11. Now I finally have the values of a, b, and c that I can use to write my equation in standard form, right? Y equals ax squared plus bx plus c. So that gives me y equals 1x squared minus 6x plus 11, which is y equals x squared minus 6x plus 11. That is the quadratic function that includes these 3 points. So now you can go ahead and pause the video and try this problem on your own. So here's how you set up the equations for this problem. So when you do the equation 1, negative 2, you get negative 2 equals a plus b plus c. 2, negative 4 gives you negative 4 equals 4a plus 2b plus c. And 3, negative 4 gives you negative 4 equals 9a plus 3b plus c. Then I combined equations 1 and 2. So once again, my strategy was to get c to cancel out of all these terms. So I multiplied equation 2 by negative 1 and then combined it with equation 1, which gave me new equation 4, which is negative 3a minus b equals 2. Then I combined equations 2 and 3 by multiplying equation 3 by negative 1, which gave me equation 5, which is negative 5a minus b equals 0. Then I combined equations 4 and 5. I once again had to multiply equation 5 by negative 1 in order to get b to cancel out. So when I did that, I found that a equals 1. I plugged a equals 1 back into equation 4 and solved for the value of b, which gave me b equals negative 5. Now that I had the values of a and b, I just plugged into equation 1, which told me that a plus b plus c is negative 2, and then I solved for the value of c, which is 2. So a equals 1, b equals negative 5, and c equals 2 gives you the equation x squared minus 5x plus 2. So in summary, remember to write a quadratic given 3 points. You're going to plug the x and y values of each point into the general equation ax squared plus bx plus c. This will give you a system of 3 linear equations that you can use to solve for the variables a, b, and c. Once you have the values of a, b, and c, you can write the equation of the quadratic function.